Hi everyone, welcome back to the channel. In today's video, we are diving into creating your very own token on Solana. And this token, in this case, in the example that we've been following along, which is basically this e-commerce application that I've been building in Solana and showing you guys all the various steps in creating that full stack experience with front and back and everything. The token is going to be called the Maya token. So I'll walk you through each step, sharing the commands in the Solana CLI to create the token, and then we'll explore how to transfer it and how to analyze the transaction details to understand exactly what's happening behind the scenes. Finally, we'll also wrap up with a quick demo using the Phantom wallet to show you the Maya token in action, the fresh new token that we are going to create. Before we get started though, if you find this presentation helpful, please don't forget to like the video, subscribe to the channel, and hit the notification bell so that you get immediately notified as soon as I drop my next video, which, by the way, it's going to be a direct continuation of this topic, because then I'll show you the programmatic usage of this token, but I'll tell you a little bit more about this at the end of the video. All right, so with that out of the way, let's jump right in. So let's talk about the token creation steps. So all the docs that you need are in this link. I'll drop all the links in the video description below. There are a few more that I want to include in there. But I thought that this video format is probably a little bit more helpful, and I'll give you my experience of using these steps that are mentioned in the Solana documentation, and some of the things that I think are useful. It's useful insight that is not directly explicitly mentioned in the Solana documentation, which again, as I said, is very good, but I'll link this back to some of the learnings that we took from the previous videos about program-derived addresses, for example, and how to maybe dispel a misconception that a lot of people might have, which is whether these non-Solana tokens, whether they are directly in your wallet or whether they reside somewhere else. We'll talk about that. We'll talk about the special ATAs or the token accounts, which are these special PDAs, as I discussed. So we'll talk about all of this. I think you'll really enjoy this session today, which is going to be connecting the dots on a lot of the stuff that we've been talking about over the last few videos. So the first step here is to create the Maya token mint authority. So the mint authority is going to be basically a new key pair that is going to be associated with your token. And the command, and this is, so this command that you see here, as I said here, it's basically used to generate a vanity address. I quite like this thing, the vanity address. And it's used as in this manner. So you run the Solana keygen command, then you specify the grind command line sort of argument, and then the flag, which basically says, starts with, and then Maya :1. Maya is basically going to be, this is whatever you want it to be. It's just the few characters that are at the start of the address. This is obviously super useful because as these addresses are often many, and it's difficult to understand which one is which. So if they start with something that you are familiar with, it makes it extremely easy to quickly spot each of the addresses and immediately tell what they actually are. So highly recommend you do this. And then the one here is basically just saying that just generate the one key pair. That's it. If I had here 3, it means that it's going to generate like 3 key pairs that start with Maya, right? So you then set your CLI to the mint authority. So you want to basically, so for the following steps to work precisely, you want to set your Solana CLI. I've been using Mac as I've been discussing over the last few videos. So in my Mac, I basically just, but I presumably this should be identical in the Windows if you're using Windows. But you just say Solana config set key pair, and then in this case, obviously the Maya key pair that you generated in with this previous command, you're going to now use it here, right? So you're going to say set it to this token authority key pair that you just generated. And then you can check that it's working, as I say here, by calling Solana config get. So you obviously, make sure that it's actually pointing to that right to the new key pair that you just generated. And then obviously if you run Solana balance, well, because it's a new key pair, you'll find that you have 0 SOL in there. So you need to run a command to airdrop some SOL. Obviously this only works, the airdrop command only works obviously if you are in the testing, in the devnet or testnet, but it doesn't work in mainnet, obviously. It would be great if it did. So Solana airdrop 5, in this case, it worked seamlessly for me. A lot of people have claimed maybe this was a limitation in the past, but at least in the devnet, I've noticed that at least doing Solana airdrop 5 once, not if you repeat it too many times, because if you repeat it too many times, you'll get like too many requests kind of type of error. But if you do it at least once per day, you can probably get it. So I ran this and no problem, it worked for me with 5. Some people claim that you have to put like maximum 1 or 2, but I used 5 and it does work. So now we create the Maya token mint address, the factory, as I say here, the factory for the tokens, or the token factory. I like to describe this as the token definition address. It's where you define your token and where all the useful information about the token is going to reside, including the pointer to the metadata, etc., which we'll cover in a minute. So the way you do this is you first create the, same as before, you run the Solana keygen grind, and now I called it to start with MNT, MNT as in mint. So this is going to be the definition of the token, the mint address of the token. And one thing to note is that, you'll see this when you start running these commands, the mint. So the longer this prefix is, the longer the command will take to finish. So this one, for instance, which is 4 characters, Maya, took a lot longer to run than this one, which is only 3 characters. It didn't take a lot longer, but it was significant, the difference between the two. I guess I never tried with 5, but it will probably take a long time, because I think it's a little bit exponential. So if you run with 1 or 2, it's super fast. When you run with 3, it's significantly slower. With 4, it's even more slow. So you get the picture. So I wouldn't advise going beyond 4. So now that you have this mint address, now you can actually run this command, which is SPL-Token create token. You specify the program ID, which is this one here that you see, and it has to be this one. So this is the token extensions program. And as you can see, we are specifying the enable metadata flag. This is basically a way to tell the program that we have further information that we're going to provide later, which is basically the metadata. And the metadata is it's a JSON file plus an image for the coin. So this is the way to specify that we want to add that metadata afterwards. after creating the token. One of the things that you'll see here is that, or you will see in the documentation when you look into it in detail, and I have more information about this in the next slide, is that you can configure like lots of different flags. Like you can add over and above this enable metadata. There is a ton of other flags that you can pass into it. One of which is the decimals flag, which basically to specify how many decimals your token is going to get. If you do not set anything, the default is 9. So I didn't specify anything here, so I'm going to have 9 decimals as the for the token that I've created. So this is the output that you see from running the previous command, create a token. So you see in your console, you'll see creating token, then it shows you the mint address that you've created initially under the program, and this is the token address that we just talked about it. So this is basically the Solana token program that you're using or calling via the CLI to create your token. So to initialize the metadata inside the mint, and then as part of the output of running this SPL token create token, what you'll see is that it gives you instructions on how to add the metadata for that as part of running that command, which is super useful, right? So it's already telling you the next steps. So well done, Solana team. It's fantastic that you're gently leading your developers to the next steps. So it's great. Well done. And they even tell you what you need to run. So this is one of the commands that I'm gonna show you today that I ran, which is SPL token initialize metadata, and then the address of the mint address for the token. You'll have a token name, a token symbol, and a token URI. I'll show you that in a minute, what that looks like, but it's exactly, it's just going to be defined in the metadata.json file. And specifically, they say this so that you don't forget, and sign with the mint authority, right? So this is the reason why, in the beginning, I told you to, when you generate the mint authority, which was the very first key pair that we generated, remember that I told you do your with the Solana CLI, do Solana config set to that mint authority, and this is the reason why, because now when you run these tokens, it's signing with that key pair. So don't forget to do that. And as you'll see here, it basically says it includes, this other information in the output of the console. Again, it confirms your mint address. It says it's decimals 9, and it has a signature which you can check in the Solana block explorer. As you can see here, there are many extensions which can be enabled in the CLI. We just used the one metadata flag, which is this one here, enable metadata. But you can combine multiple extensions together. However, some extensions would either not work or not make sense to combine. So, for example, one of the examples that they give in the documentation is that you do not want to add the transfer hooks alongside the non-transferable token extension, because it would not add anything to the token and only add cost to create. Which, if you can think about it, it's actually quite understandable, because the transaction size would probably be bigger, but because they're not compatible flags, it's just adding cost and not achieving anything useful. So yeah, when you start, I've not looked into all of these extensions. I will definitely be looking into some of these extensions in the future. But so far, I've only used this enable metadata one. Right, so As part of creating the Maya token, the metadata PNG file, the metadata that you need to add to your token, let's start by adding the image file. So in our e-commerce, so I'll just read through very quickly each of these steps, it's easier. So in our e-commerce tab, this image is obviously going to be stored in Shadow Drive. So as you know, I've been talking about, so I've been using Shadow Drive so far, super happy with it as my decentralized storage application, decentralized file storage application. And so, yeah, so this is the first thing that I need to do is to upload the image that is going to be used for this new token to Shadow Drive. So we need to create two things. We need to create the image for the token and the metadata.json file to also upload to Shadow Drive. So I highlighted here a really important aspect. So the image for the coin should be square and either this size or that size in pixels and less than 100 kilobytes if possible. Now, the 100 kilobytes is not strictly speaking something that you absolutely have to obey, but it would be really nice if you can keep as close to it as possible, I guess for performance reasons. So on a Mac, you can check your image file with a command like this. So I used the sips command because I had like an image, but I wasn't too sure what was the sort of the size of that image. So I basically ran this command and very easily, replace this with your file path, and it will tell you exactly, how many pixels width and height you have in that image. If you need to resize it, which was my case, I had to install again, these tools are completely your decision to, to use whichever ones you want. These are the ones I use, but you can use whatever you want, of course. So I used PNG Quant, and then you install it with the command. It's very easy to install it on Mac, and then you can say PNG Quant quality 120. By the way, there are several different ways you can specify the quality. I'm not going to go into the nitty-gritty about how to do that. This 1 to 20 is one of the lowest quality settings that I found worked for me, because every time I chose a little bit higher quality, I always had the image being too big. So I ran this, and as you can see, you specify the target file name and the original file name that you're trying to transform, and it will give you the results. So in my case, as I say here in my comment, I managed to get from 900 kilobytes, which was roughly the image size that I had, to just about 180 kilobytes, which is, again, close enough to 100K, but ideally you want it as small as possible with, obviously maintaining the quality to the minimum level that you want. But I couldn't get it, like in my example case, I couldn't get it below 180K. So I just went with that, and it worked. So, and then obviously I uploaded to Shadow Drive. Again, I'm not going to go into the details. I have a video where I've actually went into a lot of detail on how to use Shadow Drive, so I'm not going to go into that. So if you want to have a refresher on Shadow Drive, just watch one of my previous videos, which I talk about decentralized web application hosting. And I go into that detail about Shadow Drive and Shadow Drive, useful Shadow Drive command line tool options that you can use to manage your files. So in this case, I upload the image there. Again, I'm using a custom sort of RPC for this, which is the Helios RPC. It's great, and in this case, I'm using the free version of the RPC, so even better. But obviously, when you go to production, I'm sure that I'll switch to a paid a paid subscription. No, the metadata.json, so when we create this metadata.json, this is what I put on mine. So as you can see, I gave it a name, Maya coin. I gave it a symbol, Maya. I gave it a description, Maya loyalty program coin. And then the image, which obviously resides in Shadow Drive in my case, I gave the where the image is. Obviously, this is your account in Shadow Drive, and this is your image in Shadow Drive. Once these two files, so the image and the metadata.json file, are in your decentralized file storage, again, could be Shadow Drive, could be whatever you want to use, you need to run this following command. And this is when the fun starts, right? So you do SPL-Token, initialize metadata, you specify your mint address. This is the one that we generated earlier. And then you specify, actually, it didn't make much sense to me. Why do I have to specify this again? Given that I am providing this in here, the method, it feels a bit redundant, like the program can figure this out by going to this address. Anyway, I thought this is what I found in the documentation, that I should run it like this. This is what I tried and it worked. So I'm not complaining about it, but it's just weird that I have to specify it. I could try. Maybe next time I can try without specifying this, but only specifying the URL and see if it works. But this works. So if you follow for your metadata initialization this approach, it worked for me, so it will work for you as well. And yeah, congratulations. So after you run this, you can actually go to your Explorer in Solana, and you can actually have your first view at the token in the Block Explorer, which is super exciting. I was very excited the first time I saw this in the very beginning, the very first day that I created this. I'll show you this in a minute in the browser, so you can have a feel for it. But it kind of looks like this, right? So I'm showing you now here on the slide. You have your Maya token with your image that you uploaded, and all this information is there. So your mint address, which you created, as you can see, it's easy to spot that it's our mint address because it starts with the prefix that we defined. Staying here for the mint authority, again, starts with Maya. Great, it's the one that I use to sign the transactions. You can see the metadata the metadata is basically stored in this mint address, which makes sense. The metadata pointer authority, again, is the same one as the Maya address. Yeah, all makes sense here. And then finally, we have the URL to the metadata.json file, which again makes a lot of sense. We defined that when we called that CLI command. So now that we've done that, what we need is to mint. So we defined, so up until this point, what we did was we created a token sort of definition address that contains all the metadata about the token, etc. But we didn't actually mint anything yet. This is what this command is all about. But before we mint, we need to create an account that will hold the tokens that are going to be minted. So that's what this command does. So you run SPL-Token create command with your mint address, which we already know. And then this is the output that you get, creating account. This is automatically generated. And then you get your signature that you can obviously go to the Block Explorer to validate what happened there. And now, as I'm saying here, we can finally mint the tokens because now we have that address, which is going to be where the tokens are going to reside. So in this case, for example, in this example, I'm saying SPL token mint. You again provide the same mint address, and then you specify how many tokens. It can be 100, 1,000, 1 million, 21 million, can be anything you like. So it then says minting, so this is the output that you see, minting 100 tokens. Again, specifies the same address that you already know, the token mint address, and then the recipient. Now, obviously, this recipient is the same recipient that was created earlier. Makes sense. No surprises there. You can also, I believe in the documentation, there was a reference to the fact that you can also specify a different account by adding the address at the end of the command. I didn't try that, but it makes sense that you would be able to do that. So let's talk about, so we're going to spend a little bit of time here. I think there's a lot to be discussing here. So how do we now that we have the token, how do we transfer tokens to any other wallet address now that we've minted the tokens? And again, I'll show you in a minute the in the Phantom wallet all of this stuff. So you can get the balance of your tokens. So remember that your Solana CLI is now pointing to the mint authority, right? So because of that, your mint authority now holds the tokens. It's the holder of all the minted tokens. So when you run SPL token accounts, this command, you'll see a printout in your console like this, token balance. It shows you your token mint address, and then it says 200 in this case because I used 200 to start with, like when I minted the tokens. And now you can transfer the tokens. So it's great. Now we had like visual confirmation in the command line that the tokens are there. So the previous command to mint it actually worked. Great. And now you can transfer the tokens. So you can say SPL token transfer, which is the command. Then you provide the same address that we keep seeing over and over again. So this is the mint address. And then you can say, of the 200, I want to transfer 10 to a target wallet address. Now, this can be any Solana wallet address. And then you have to specify fund recipient. We'll talk about this particular aspect in a minute. So when you run this is the output that you see. You see transfer 10 tokens, great, that's what we wanted. Sender, it's the same address, it's the account address that was generated automatically earlier when you created the token account. The recipient, so this is the wallet address that you specify here, so that's why I've put it in the same purple color to make it kind of easy to understand. Recipient associated token account, so this is the recipient PDA, and this is where I need to stop and provide kind of a big explanation about this, which I find I think it's really useful insight because some of you might query, like, what is this new address that I'm seeing? You know, I thought it would be this one that would be the recipient associated token account, but it's not. It's a different address. So what is this address? And let's talk about it here. So in Solana, the non-sol tokens are not directly sort of living within your wallet. Instead, they're held in special accounts called the associated token accounts, or ATAs. These ATAs are a type of program-derived addresses, or PDAs, which are obviously unique addresses generated by programs on the Solana network. We've been talking about PDAs for forever now, across all of my videos. They on and on and on. We talk about PDAs. And you probably remember that a PDA is an address generated by a program using a combination of the program ID and the seeds, right? We talked about this in one of my really early videos, like maybe my third video that I've done on Solana smart contracts. We talked about PDAs and seeds and all of these things. So one of the things about ATAs or associated token accounts is that they are used to hold tokens for a particular wallet and a token mint. So basically, an ATA is a special kind of PDA which is derived using your wallet address, your public key, and the token mint address. And when you combine these two, the address derivation basically results in a unique ATA for each wallet. So every person will have their own ATA, I guess. That's kind of the way, it's the easiest way to explain this. And when you run the SPL token transfer command that we saw earlier, there are a number of steps that this command goes through to execute successfully. So the first step is to check for an existing ATA. So have you already has your wallet received these types of tokens before? Like, do you have balance with these tokens? If not, and if the ATA is not present or is absent, and obviously this is where this fund recipient sort of flag comes in. So the fund recipient flag it tells the system to create a new ATA for the recipient, and the sender's wallet provides the necessary SOL to make the ATA rent exempt. So yeah, so it's basically, as you know, to create a new PDA, every time you create a new PDA, that needs to be funded with a minimal amount of SOL to make it rent exempt. That's something that we already knew. The interesting thing here is that when you do the fund recipient, that means that the origin sending address needs to fund that recipient. So this process basically makes sure that the recipient can receive the tokens without needing to set up the ATA themselves. I've not done the research yet whether it's possible to have the recipient funded, but I'll do a little bit. I'm pretty sure that I don't know, but it's possible that it could be something that it can be done. But obviously, when I was using the CLI, this was an easy option that I could find to fund an account that didn't have, for instance, any SOL. So this was a really straightforward thing to try. But I'll find out the answer to this, and I'll let you guys know. What else do I want to say here? Right. So the other aspect that I wanted to sort of briefly touch on, and I think it's a really cool insight that you can take from all of this is, and this is, I guess, one of the things that you're probably now starting to realize is that the non-Solana tokens, actually, they do not live directly inside your wallet. They live in a PDA or ATA that is under the token program, right? And so what you might be thinking, if you're a software engineer that has been around for a while, you're going to start thinking, as I did, so let me get this straight. So when Phantom, again, I'm using always Phantom Wallet, but it can be any Solana wallet. But but let's use Phantom in this example, which has been the wallet that I've been using up until now. So when I click on my Phantom wallet in the browser, and it shows me the tokens that I have, how does it know if the tokens are not really in the wallet? How does it know that which tokens I have and how to display them and the balance and all of these things? Obviously, as you might probably be guessing, uh, that wallets like Phantom, they don't obviously, even though they don't hold your non-sold tokens directly, they do give you a view of all the ATAs associated with your wallet. And how does that work? So first, there is this phase of querying the blockchain. So when you open the Phantom wallet, it queries obviously the Solana blockchain to find all the ATAs linked to your wallet address. And it does this, I suspect, because there is a Solana RPC method that you can call, which is the get token accounts by owner. So I'll try and remember to put the link in the video description for this particular one so you can check it out yourselves. But effectively, this fetches all the token accounts owned by your wallet. And this Phantom basically then gets this information, and then with this, it can fetch any additional information it needs in terms of metadata associated with the token. So it gets not just the balances for the tokens, but it gets the image and all the other, the symbol, the name. It gets all of this information, and obviously then it can present it in the UI for us, which is great. So I'm just looking at my notes here to see if there is anything else that I wanted to say. Yeah, so the summary is Phantom basically acts as a window into the blockchain, showing you the tokens held in the ATAs associated with your wallet under the token program. That's fundamentally that. So the key sort of, to summarize everything, and the key takeaways from this are that ATAs are a special kind of PDAs that hold tokens for your wallet, and that wallets like Phantom, they query the blockchain calling the RPC to get to basically be able to find out which tokens you own, the metadata associated with those tokens, the balance associated with those tokens, and then basically show it in that beautiful UI that we've grown accustomed to from Phantom. And that allows you obviously to manage those tokens. But yeah, so I went into this rabbit hole of when I saw this line here, recipient associated token, and I was like seeing that other address, and I was like, yes, that's right. So this goes back to the beginning of the conversation about PDAs and, in this case, ATAs that are our PDA under the token program. All right, so let's go. So I've included a series of screenshots here for the transferring of, so this is basically to analyze the details behind a transfer of a token. I've included a series of screenshots here, but I'll also show you when we do a little bit of a demo. I'll show you this as soon as I complete the transfer. But I was, you never know when you're doing these video recordings, if the transfer for some reason doesn't work, at least I have the screenshots here. So it's always better safe than sorry, right? So yeah, so this is, this first one, it shows you the details of a transaction in the Solana Block Explorer. There isn't much to say about this particular first one, but this is where this is the really interesting one. So as you remember, every Solana transaction needs obviously to have all the accounts that are going to be modified or read from, and you can see those here. we can, now that we have the prefixes in our addresses, we can really understand what most of these are, right? So we know this is the mint authority, the my token. This let me just make this a little bit bigger for me. So this is the this 6H1 is the token account that has all the tokens that we minted. This one here is the I believe, I'm just speaking from memory, this is the one, this is the ATA for our wallet address. System program, yeah, compute token program, nothing special about this. The mint address for the token, obviously, very recognizable because of the MNT prefix. Again, this is our wallet address. This is the actual wallet address, which owns this ATA. And then finally, this basically shows the token balances, and it's very clearly saying that the 200 token, so this token account now holds 190 tokens because I transferred 10 tokens to the new wallet address, which now has an ATA, which is an associated token account, which is this one. It's the special kind of PDA that was created there for my wallet address, which is this one, and this is for the token for this token mint address, and now it has 10 tokens. Great, we now understand exactly what's going on. Isn't that wonderful? Yeah, and this is the final one here. Again, nothing like we recognize all of these addresses. The source where, again, the mint address, the mint authority, let's say, the account where the tokens are being stored, our own ATA, I guess. The wallet, this is our wallet address, the target, the recipient wallet address, the mint address for the token system, etc. So a little bit of repetition there. And these are so these are all the instructions that were sort of triggered as part of running that command to transfer. And as you can see here, there was a token 2020 get account data size. Not surprising to see that there. System program create account. So we are creating an account from this token authority. The new address, see, so this is the new ATA that we're creating associated with the wallet address. So super interesting, and again, it's the program ID that owns this one. So the token program owns this account on behalf of our wallet, which is the true owner of those tokens. Token initialized immutable owner, yep, for this account, for this ATA. And now you see here finally confirmation, initialized account. We see the account that we keep seeing all the time, the mint address for the token, and finally this is the relationship, right? So this is establishing the relationship between the wallet, the recipient's wallet, and the token. So it's basically it's everything you need, right? So it's saying for this token, we have a new relationship which basically says this is where the balance of that for this wallet resides. So yeah, so these are the 3 data points. Lovely, all makes sense. And then finally the transfer, and again all the usual things that we suspect are there. So the authority, which is the token authority, which starts with the my prefix. Great. Destination, again our ATA. The mint address, not surprising. The source, again the source is the token account. So this is when the address that was automatically generated when we we created the account and then we minted tokens into this account. The original 200 were deposited there, and then it's from there that the 10 go into the new ATA that was created. And now I'm going to give you a little bit of a demo for this on Phantom. So let me just get that window. So here we are. As you can see, we have the, so this is basically, let me just go to, let's see if I can go to back. Yeah, so this is the Maya token, effectively. I showed you this before. So this is, all the fields that we already discussed, and these are the transfers. So I'll do now a transfer so you can see. So the token can be, let me just log in. And as you can see, in this account too, I have 5 Sol and I have 2 Maya. And in account 1, I have 8 Maya. So this was the account actually in the slides you saw that I was transferring the 10 tokens into this account. So say that I want to now transfer another token. So I'm going to transfer, click send, and I'm going to send to account 2. I'm going to send 2 tokens. And I'm going to do next. So if I go back here, you'll see that I only have 6 now. I had 8, now I have 6, makes sense. If I go to account number 2, you'll see that I have now 4. I had 2, now I have 4. And if I refresh this page on the Solana Block Explorer, and I scroll all the way down, let me just scroll this down, you'll see that a few seconds ago there is a new transaction with the 2 tokens. Makes a lot of sense. If I click on it, and here is what I was describing earlier. So you see the signature, and then you see the accounts that were part of this. We discussed all of this, so I'm not going to talk about this again. You see the token balances, so it's saying that it subtracted 2 tokens from the from this address, which is the address, the ATA that was associated with account 1, and it added 2 tokens to I suspect this would be the ATA created for account 2, for my account 2 in my wallet. And as you can see here, all the instructions that were triggered as part of this transfer. And it's interesting to see the Solana composability that people often you hear people talking about this, that one of the biggest strengths of Solana is that because at the L1 level you can call all of these cross-program invocations, you can see this wonderful composition here. So it looked like just the one instruction that was called, but actually no, there was several instructions called as part of that simple transfer that you saw on Phantom. And here's the result in this transaction details. You can see the instructions. So there was the compute budget program that was called initially. Then the second one, then the token program transfer was called. You can see the new ATA associated with account 2. You can see the mint address for the token. You can see the signer, which was the original account. Let me see. use if I go to account 1, yeah, as you can see here, so 6ZP2, which is exactly this address. So it's basically saying the account 1 signed the transaction to send those 2 Maya tokens to account 2. Makes a ton of sense. Yeah, so I think this is it. This is all I wanted to show you now. So let's go back to the slides. So in conclusion, we talked about all of these things. So we talked about how to create a new Solana token, the Maya token. We talked about how to transfer the token using the SPL-Token CLI. We talked about how to transfer the token via the Phantom wallet. So 2 ways that I've shown you today of doing this. And obviously there is going to be the programmatic way of doing this via code. I will show you this in the next video. And we analyzed the transaction details to understand what happens behind the scenes. We've just done that. And we discussed the ATAs and how Phantom fetches these ATAs to display all of these tokens in your wallet's UI, which is a great UI when we use the Phantom wallet. So looking ahead, in the next video, we'll explore how to use this new token in our dApp for the purpose of rewarding loyal customers. Not only that, but also to, as I've shown, I'm talking about here. So the customer will obviously earn tokens when they purchase, let's say, bottles of wine, but they will also be able to then use those tokens to get discounts when acquiring future products, for example. So I will show you the programmatic way of doing this, which is going to be also exciting, of course. So thank you very, very much for following along. I hope this presentation gave you a real clear understanding of how to create tokens in the Solana blockchain. As you've seen, the Solana tooling makes it really easy to accomplish this task. And as always, feel free to reach out with any questions or feedback in the comments below. And stay tuned for more updates. And don't forget to, as I said in the very beginning, to like and subscribe to future content and to hit that notification bell. And stay empowered, stay decentralized. Thank you very much. Goodbye.